Hello friends, myself Dr. Nandakumar Raubale from College of Engineering Ambazogai is going to deal with numerical methods in mechanical engineering. In previous lecture we have discussed the contents of syllabus. Now today we are going to start the actual syllabus of your Unit 1 error analysis. Error analysis. Now in this, first of all, we will see significant figures. What is a significant figure? What is significant figure? Now this significant figure is defined as the significant figure of a number are those digits that can be used with confidence. The significant figures of a number are those digits that can be used with confidence. Now what is exact meaning of significant figure? Say for example, there is a dial gauge for which some readings are noted down. Here there is pointer. This pointer shows some reading here. Say here this is 40, 50, 60, 70, and here we have 5 divisions. Now the answer which we write here is 50.8. So this is at 4th division, so 50.8. We write answer as 50.8. So this answer which we write is with confidence. Now sometimes this is represented on a dial gauge. Say for example, a meter reading, speedometer reading shown in your vehicle. Say for example, this is 87324, and here there is a running number, so here it shows 4 and 5. So now while writing answer, what you write here is 87324.5 you are going to write, because this 4 is about to move out of this dial and 5 has entered completely. 5 has entered and 4 is about to move, so you will say that it is 0.5 not 0.4. It is your confidence that you are saying this reading is 87324 kilometers is the running of your vehicle. Now many times you find that the number is written like this: 0.0001845. So here what is a significant figure? So these zeros which are used just to locate this decimal point, not for any other purpose. So its function is to locate this decimal point. So here You will see the zeros are used to locate just a decimal point. So beyond that, there is no use of this. So here, this value is written up to 4 significant figures. Say for example, if we write this value as 0.0001845, then also this result is written with 4 significant figures. Now, what we say, zeros are not always significant figures. Zeros are not always. Zeros are not always significant figures because they may be necessary to locate, just to locate a decimal point. So here, zeros are not the significant figures. Now, the trailing zeros are used in large numbers. The trailing numbers, sorry, trailing zeros are used in large number. Are used in large numbers. So for example, we use this number as 45300. May have 3, 4, 5 significant figures, significant digits, depending on whether the zeros are known with confidence. Such uncertainty can be removed by using scientific notation as 4.53 into 10 to the power of 4. So this number can be written as 4.53 into 10 to the power of 4. Or else, if we write this as 4.530 into 10 to the power of 4, makes no difference. Or we can write this as 4.5300 into 10 to the power of 4. Answer is going to be same. So designate that the number is known to 4, 3, 4 and 5 significant figures. So here we say this number is what we say is known to 3, 4 and 5 significant figures. So here this is known to 2 significant figures, this is known to 3 significant figures, this is known to 4 significant figures. So importance of significant figures. What is the importance of significant figure? So number 1, to look into issue where our approximation is acceptable. to look into the issue where approximation is acceptable. Approximation is acceptable in the sense, so for example, we are using a number pi. Pi is equal to, actual value of pi is 3.141535897 and so on. But what we do, pi is equal to, we take this answer as 3.142. Sometimes this answer is acceptable. So what we say, significant figures enable us to use it with confidence, that instead of this lengthy number, we are using a short number. We are going to truncate other decimal points, and only up to 3 decimal points we are using it with confidence. So this is the role of significant figure. So the omission of remaining significant figures, so this we are going to omit, so this omission of significant figures is called as round off error. So round off error, so this value is removed from this actual value, true value, so error is introduced, and that is called as a round off error. Such numbers cannot be represented exactly, so this number cannot be represented exactly. At that time, what we do, we take its approximate value and we proceed with the calculations or analysis. So in such cases, the error is introduced, and that error is known as round off error. Now we proceed to the next term, accuracy and precision. Precision. What is accuracy and precision? Why error is occurred, that we want to see. The error associated with both calculations and measurement can be characterized with regard to their accuracy and precision. So always it is said that there is no manufacturing system which can fabricate or manufacture a part of accurate dimension, and even if it is manufactured with the accurate dimension, there is no device to measure the accurate dimension. So error is bound to occur in the manufacturing process or in the measurement processes. So always error is associated with manufacturing and measurement. Now the error associated with both calculation and measurement can be characterized with regard to their accuracy precision. Now, what this accuracy is? What is accuracy? Accuracy refers, it refers to how closely a computed value or measured value agrees with true value. What is exact meaning? Say for example, true value. For the dimension of shaft, the true dimension or diameter of shaft is say 10 mm, and you are going to measure this diameter of shaft. Say this is the shaft having diameter 10 mm. You are measuring its dimension 3 times. So first time answer is D is equal to 10.05 mm. Second time it is D is equal to 9.999 mm. Third time D is equal to 10.002 mm. The true answer is this. So these answers are not wrong. The values which you have measured are not wrong, but these answers have got error. So here error, a difference between true value and the measured value is 0.05 mm. In this case, this error difference between 10 and 9.999 is 0.001, and here error is 0.002. Which error is minimum? That we have to see. So this error is minimum. That means the second answer is more accurate. That is nothing but this answer D is equal to 9.999 is very close to the true value, and that's why we refer second answer as more accurate or having higher accuracy compared with first answer and third answer. So this is what we call as a accuracy. We define accuracy is degree of closeness to the true value. So what is true value? Actual diameter of shaft is 10 mm, but we are going to measure it using some devices. So we measured it 3 times. First time we have used some one device, second time we have used some other device, third time we have used one more device, and we have noted down the answers, and from these answers it is revealed that the second answer is very close to the true value. Therefore we say that this second answer D is equal to 9.999 mm is more accurate. So this means closeness to the true value. Now coming to the precision. What is this precision? So this precision, it refers to how closely individual computed value. Individual computed value or measured value. Measured value agree with each other. So what is the exact meaning of this precision? Say for example, just now I told you first measurement for the diameter d is equal to, it was 10.05. Second measurement was d is equal to 9.999 mm, and third answer was d is equal to 10.02 mm. So this is first answer which you have obtained, you have measured is 10.05, second is 9.999, third one is 10.02. So these answers which you have measured are very close to each other, but fourth time you are going to measure the dimension. Say for example, d is equal to 11 mm. So first answer is 10.5 and last answer is 11. So these two answers are not close to each other. So here there is no role of true answer or true value. True value is, say for example, d is equal to 10 mm. So it is not closeness to this 10 mm, but closeness of this measured value and with the previously measured values. So if all answers are same, approximately same, then we call that the results or individual values which you have computed are close to each other. So these answers must be very much close to each other. Then we say that the device is more precise. Say for example, you are measuring diameter of a shaft 10 times using same instrument, same shaft, and all the times the answers are same or with very close values, then we say that the device which we have used to measure the diameter of shaft is more precise. एक ही आपने वर्नियर कैलिपर लिया है, सेम शाफ्ट का डायमीटर आप मेजर कर रहे हैं, 10 बार मेजर कर रहे हैं, हर बार आपको जो भी आंसर आ रहा है, जो भी डायमीटर आ रहा है, वो एक दूसरे से मिलता जुलता आता है, तो उसको क्या बोलते हैं हम, प्रीसाइज बोलते हैं. It is not necessary in this case that the answers which you are going to obtain are close to this true value, but these answers are close to each other. A true value is 10 say, but if you are going to measure first time diameter of that shaft is 12 mm, maybe this is having error. Second time you are going to measure it as 12.01 mm, d is equal to 11.99 mm, then fourth time d is equal to 12.001 mm. So these four answers or the values measured are very close to each other. No doubt these answers are not accurate, not close to the true value, but these measured values are close to each other. That means the device which you have used is more precise and is giving same answers whenever you are going to measure. Thus the precision signifies what this precision is going to signify. Number one, precision signifies number one, what it signifies, the number of significant figure representing the quantity, the number of significant figures representing quantity. Second one, the spread in repeated computations or measurements of particular value. The spread in repeated computations or measurements of a particular value. Of a particular value. So here number of significant figures representing quantity. So here how many so many times you are going to measure, the results are same, and spread in repeated computations or measurements is of a particular value. So these answers are very close to each other. So these answers are close to each other, and maybe you have measured n times, the same results are repeated. And these concepts can be illustrated with the example set. So here we have some diagrams. What is the difference between precision and accuracy, that we will see. Now you see example of target practice. Now what is target practice? Now we will discuss target practice. So a person is making a practice to fire bullet, and his aim is to fire this bullet at the center of this circle. So there are four examples. There are four persons who are going to fire on this target practice. So X person is going to fire his bullet, and 5 times or 6 times, say 7 8 times. So his target is, say here, first time, second time, third time, fourth time, fifth time, sixth time, seventh time, and eighth time. So 8 chances here, 8 opportunities are given to a person, X person. Then he is going to fire, uh, and his target meets with these points here. So actually his aim is to fire at the center of the circle, but instead of firing at the center, he is going to fire at this particular zone. So His targets achieved are not accurate but are precise. So these targets which he has achieved are very close to each other but not to the center of circle, means this is inaccurate. Inaccurate but precise. But precise. Very close to each other. Second person is asked to fire, then he fires here. 1 2 3 4 5 6. So neither these 1 2 3 4 5 6 7 8. So the target achieved by second person is neither close to the center, means not accurate, and not close to each other. So this is inaccurate and imprecise. And imprecise. In third case, you can see the target achieved by a person is 4 5 6 7 8. So in this third case, the target achieved is very close to this center. So this is accurate, but not, but imprecise. Accurate. These targets achieved are very close to the center, but not close to each other. So this is accurate, but not precise. And fourth person is going to fire at the center. So fourth person is going to achieve target accurate as well as precise. So this is the difference between accuracy and precision. These are very close to each other, or not close to the center, precise but not accurate. Here these are neither close to each other nor close to the center. That's why it is inaccurate and imprecise. In third case, these are close to the center, scattered about the center but not close to each other. So accurate but imprecise. In third case, all are very close to the center and close to each other. So that's why these are accurate and precise. This is what about accuracy and precision. Today we will stop here. In next lecture, we will discuss about the approximate and true error. What is approximate error and true error? As this is first lecture, you must become familiar with these videos, and tomorrow onwards we will be dealing with this numerical method for a longer duration, not the smaller duration. So next video lectures will be of 1 hour approximately, at least 45 minutes.